So this problem says, one hazard of space travel is debris left by previous missions. Hey, guys, don't want any background noise. So one hazard of space travel is debris left by previous missions. There are several thousand objects orbiting Earth that are large enough to be detected by radar. So for instance, the US military keeps track of roughly 15,000 objects out there, of objects size bigger than baseballs. Okay. The idea is the following: you guys all know that if somebody shoots you, it hurts, right? What's funny about it? Nothing. So, what's that? So here's the physics fact. So, if you hold a bullet steady and throw yourself at the bullet at 1500 meters per second, that's equal. Yeah. That's true. So if you're traveling in space, you're traveling pretty fast. You're traveling at about 8 kilometers a second. So even, well, it wouldn't have anything stationary, but if it was traveling at the same height, it's coming in the opposite direction. That's the height at which the space shuttle travels. So if you hit something in space, you're likely to get damaged. And if you happen to have spent $500 million on this thing to put it up there, you don't want it getting damaged. Okay, so that's the idea. Or you could be doing a spacewalk, and a little piece of debris comes and punctures your spacesuit. That's not a good thing. Yeah. So, one hazard of space travel is debris left by previous missions. There are several thousand objects orbiting Earth that are large enough to be detected by radar. But there are far greater numbers of very small objects, such as flakes of paint. Calculate the force exerted by a 0.1 milligram chip of paint that strikes a spacecraft window at a relative speed of 4 times 10 to the power 3 meters per second. That's 4 kilometers a second. So here's a speck of paint traveling at 4 kilometers a second. 4 kilometers is roughly from here to the beach. That's how fast it's traveling. Okay. Given the collision lasts 60 nanoseconds. Okay. All right. So force is given by change in momentum over change in time. Okay, so this speck of paint strikes the window and then comes to stop. So you want it to come to stop, the final velocity to be 0. Okay, and we are just calculating the magnitude of the force. So it's mv initial divided by the time over which this. Okay. All right, so the mass is 0.1 milligrams. 0.1 milligram is 10 to the minus 3 grams, and a gram is 10 minus 3 kgs. So this is 10 minus 6 kgs. And its velocity is 10 to the power 4 times 10 to the power 3 meters per second. And the collision time is 10 minus 8 seconds. Okay, so here's the force that the spacecraft window exerts on this chip of paint to stop it. And so by Newton's third law, that's the force on the window. And what you're worried about is, will you get a hole in the window? Okay. All right, now in this thing, let's take care of powers of 10. You get 10 to the 2, 10 to the 5. We'll spend 1 here, so 2, 5, 4, 3. Okay, so that's 40 divided by 6 into 10 to the power 3 newtons. Okay. And 6.7 into 10 to the power 3 newtons. All right, so that's 6,700 newtons, and 670 newtons is roughly your weight. So that's the weight of 10 people. What? And so that's the force. Well, it lasted a small time, but think of this. Well, let's say 10 people stand here, that's no problem. On a window, if you stand with wide feet, then that's no problem. But imagine 10 people standing on this thing, and that's pressing down on the window, because the speck of paint is very small. Okay. So the pressure would be quite high. All right. So the problem itself was easy. So, right. Yep. Right. Yeah, you've stopped the speck of paint. That's what we are assuming. If it bounces off, the problem would be worse. No, if it went through, the force was small, but the smaller force broke you. Yeah. If it bounces off, the force is greater.